as you may know, my first midterm exams are beginning, like right now is going on. So tomorrow is my science exam actually, so I'll be able to teach you guys a lot. So for my portion is lesson 1, physics, laws of motion, as well as lesson 7 or chapter 7 or unit 7, atoms and molecules from chemistry, and plant physiology and plant anatomy in biology lesson 12, and zoology in lesson 13, structural organization of animals. So now science, preparing for my exam, obviously first midterm. So 10th grade syllabus. So if you guys have any doubts, so I'll be just doing the answers and what they do and etc. So I'll be teaching you guys some very important concepts which have a 70% chance of coming to the exam. So first let's do physics, shall we? Because since I'm going to be a physics teacher, chemistry teacher in my days, so I'll just teach you guys physics. Okay, so they'll definitely ask define inertia. So inertia. So if they ask you guys about inertia, just say that inertia why is not operating graph? Well, wait guys, okay. Lesson 1, laws of motion. So the first thing you'll definitely ask is what is inertia and give its classification. So if they ask about inertia, just put inertia. Okay, I'll just give you guys some key points because I don't want to waste time by just writing the whole full answer. So just write an inherent property of a body to resist any change in its state of uniform or rest in a straight line unless influenced by any unbalanced external force. So this is inertia, and they'll probably ask define its classification. So its classification are as follows: inertia of rest, inertia of motion, inertia of direction. So please look at the answer, guys. So I'll just tell to you guys, explain. So inertia is an inherent property of a body to resist any change in its state of uniform or rest, or state of rest or uniform motion in a straight line unless it is influenced by any unbalanced external force. So a body can just so imagine you're just walking and they just pushed you. So how do you react? Like, you just feel like they give a huge amount of force, then you'll just fall down. So that is known as inertia. So just going in a uniform motion in a straight line. unless you're pushed by someone else, that is one is considered as inertia. So guys, so that is the main thing I'll ask. So I hope you understood. What is this? Then another important answer, differentiate between mass and weight. Mass and weight. So the first thing is that it is a fundamental quantity and weight is a derived quantity. That's point number one. And so they say that mass is they have like, okay, so to be honest, there are like many verses with mass, like, you know, such as weight, kilogram, gram. So mass, it is defined as the amount of matter contained in a body and the second one is that it is defined as the gravitational pull acting on the body. Next thing is that its unit is kilogram and its Newton is Newton. And weight remains the same. And it is vice versa, which means it will change from place to place. Like the Earth's gravitational pull is different. Earth is not equal to Moon. The gravitational pull is not equal together. So G is the gravitational constant. And last one is that mass is, you know, measured by physical balance. And by spring balance. So this is it. Nobody's watching my live. I mean, it's kind of sad, but at least I'll try to upload it. You know, guys. Then I'm probably done. So mass is a fundamental quantity, which means that fundamental means a lot of matters, like such as mass has many other names, such as, you know, kilogram, gram, a lot of things. And weight is a derived quantity, means it has been derived by someone and it has been stay the same. So mass is so mass, imagine this is a whiteboard marker and this whiteboard marker is 32 grams. 32 grams. So the mass of the whiteboard is 32 grams, which means the amount of matter contained in a body. And weight. So, the whiteboard, it is held on to the gravitational pull acting on the Earth's core, so it is standing. If it wasn't for the gravitational pull, it would have been floating. So mass is considered, its unit is considered to be kilogram, as well as its unit is to be Newton, N. And mass remains the same, as well as weight. It differs from place to place, such as, you guys, I've given you guys an example. From Earth, the gravity is way different than the moon. The moon is much more lighter and the Earth is kind of denser. And mass is measured using physical balance, and weight is measured using spring balance. Important 2 mark. I'll give you guys to read, so I'll just be right back. I'll be right back. Oh, there's a lot of water. So as I was telling you, mass is the same, but weight, it remains weight is the same as mass differs from place to place. Oh, I see a viewer, and I don't know who he is or she is. You should give me a like, and that's all I need. So thank you so much for watching my live, and I hope if you're a student, I really hope it's going to go well for you. So yes, thank you so much for watching the live. I'm literally congratulating you because you're my first viewer for the first 14 minutes, or was 15 minutes. I'm not saying it was. So the next thing they will probably ask. Okay, so I have basically defined inertia, which is Newton's first law, and the second will be Newton's second law. second law because it's actually kind of big. So Newton's second law changed that the force acting on a body, the force acting on a body is directly proportional to the rate of change of linear momentum to the change in momentum that takes place in the direction of the force. So F is directly proportional to final momentum to initial momentum by time. So this is the formula. It is also defined as F is equal to m into a. So, to be honest, Newton's second law. So Newton's second law states that the force acting on a body is directly proportional to the rate of change of linear momentum to the change in momentum that takes place in direction of force. So imagine this pebble marker. So if I grip it, that means I'm applying some force to it. So that force is directly proportional to the momentum. So at first I grip it kind of slowly, then I grip it kind of tightly. So the first gripping is known as mu, which is initial momentum, and mv, which means the final momentum, which means I am completely grasping onto this whiteboard. So mv means final momentum, as well as mu will get initial momentum. And by time, so the force depends on time, because from time I'll slowly lose up my energy and then it'll fall down. And it is not as proportional because it states up to the relation of the momentum as well as the initial. So yes guys, so and also there's also another thing known as force is equal to m into a, where force depends on the mass and acceleration. So imagine if there's like a thin boy running 5 laps and a fat boy running okay guys, I'm not body shaming, this is just for reference. So a fat guy running around the ground 2 laps. So who will run faster if the skinny guy got 5 laps and the fatty guy got 2 laps? Of course, to be honest, the skinny guy. If also could be the fatty guy, but to be honest, the skinny guy will win. So the force you're applying to your legs will depend on your sprint as well as your swift running. So yes guys, that's all for Newton's second law. The thing is that you gotta understand well. That's the main concept of these Newton laws. If you understand it, then it will be very, very good, because there are 3 laws in detail. They'll definitely ask it for 4 marks or 7 marks to be honest. So after doing this short answer, then I'll go to that chemistry short answer. So the 9th question states that why a cricket player holds down his hand while grabbing the ball. So imagine you're a player over here and someone hits with the bat and the ball is coming towards you at 15 miles per hour. Sorry, you guys have MPH. So MPH. Okay, let's not put 15 but 25 MPH. So if the ball directly comes with hits you, you'll definitely get some sort of hit. Even though the air that is surrounding the place will try to reduce the 25 to 23 or 22. That's it. That's the least the air that can do. But to feel less pain, if you're about to catch the ball, well, okay, so for brief example, imagine this ball. I'm like swiftly tapping the ball. Oh my lord. Something just fell, I don't know how, but it's fine. Okay, so I'll do it small, guys. So imagine this. So I'm putting a quick time and a huge force. A quick and a small force, of course. And imagine I'm doing like this. So you think the ball feels ready? No. So that's why the cricketer use this type of fundamental law. So imagine this is the ball and I'm about to catch the ball, so I'll put the ball grasp in my hands, then I'll slowly move backwards because the force acting on the ball is touching my hand, which will also impact my hand. So to reduce the force, I'm actually grasping and then pulling back. Because imagine if you just pull like this, then your hand will kind of get injured, to be honest. So that's why they use this type of thing. So if the ball, okay, so imagine same question, same concept, but imagine the fielder is over here and the batter is here. So imagine the ball is going 35 miles per hour. How do you think the fielder might be able to catch it? It's simple. Impulse. Impulse. There are two types of impulse, which means higher force acting on a body on a small, it's not a small but a quick mode of time. This one, lower force acting on a body for a slower mode of time. So which is it, type 1 impulse or type 2 impulse? I mean, which type of impulse is the cricketer or the fielder using first? Higher force. Imagine this kind of sharping and then he catches like this, that means he's gonna feel a high impulse. And the second one, lower force acting on the body for a short period of time. So of course he's gonna, okay, so imagine I'm the fielder over here, which is kind of crazy of course. So imagine the ball is coming towards me, then I grab it, then I slowly pull my hands backwards so that I distribute equal amount of force all around my body, so that I will not only feel the force like only in my palm of my hands. It also grabs to my hands and also go to my arms, shoulders, my whole body. Then it will convict. So that's basically it about the ninth answer. So the 10th answer. So the question states that how does an astronaut float in a space shuttle? So we all know that an astronaut doesn't float in space. So they're under the condition of free falling or free fall. So imagine that this is the Earth. And this to the moon. So, what's the definition of orbital velocity? So we have already learned this in 9th standard universe lesson. So it means that the amount of force required for a satellite to reach on the surface of a planet or the moon by under free falling condition, which means it will distribute the forces or not the equal part of the force. So imagine there's an astronaut over here with the safety precaution, of course. So he's not floating or something, guys. Maybe he's attached to a rope. It doesn't matter. He is not floating but free falling, because between the distance of the Earth and the moon there is high orbital velocity, which means no gravity or gravitational pull. So it means, even though it feels like they are floating, they're free falling. Plus, the thing is that they also feel weightlessness. So imagine you're going on a roller coaster and it goes high, then you feel like your body weight is low, and if it goes down, then you feel like your body weight is kind of high or increased. So astronauts are not floating but free falling around the Earth due to the huge orbital velocity. Since space station and astronauts have equal acceleration, so this rocket or space station will have to traverse through the space doesn't it? So since it does that, they have the state of free fall condition, and they also have equal acceleration. So if the rocket moves by 2 mh, the astronaut also moves 2 mh, but they also have the same speed. So they cannot move as they wish. It depends on what it depends on what they're holding on and what pushes them off. So this is free fall condition. So free falling condition depends on gravitational force like mg by h and quantity of 2. This is the gravitational proportionality. So that's it. We are completing laws of motion, short answers. Now let's go for, and also come later for detail answers, guys. Don't worry. Next we'll go for chemistry, atoms and molecules. Okay, I know a lot of you guys are thinking that physics and chemistry are so boring. Why am I teaching my friend? And I don't know what is even watching my life, but to be honest, only one and they left. But it's fine. You are the only reason, guys. I got motivated a lot. So, yeah. So, let's go for chemistry. What will they ask? They'll ask isotopes of oxygen and percentage abundance. So guys, 1 second. So just see there guys, since I have completed one lesson, I'll give you guys a small amount of break. So I'll sit here guys. To give you guys some important questions that will definitely come for any exam, to be honest. So first thing will be that of physics lesson 1, conservation of linear momentum, which is a detail, and in biology lesson 13, male reproductive system of rabbit, and they'll also ask types of inertia and Newton's laws. Next will be physics 2 mark, solve the problem, and chemistry 4 marks, solve the problem. Next they'll definitely guys, they'll ask chemistry lesson 7, relate the relationship between relative hydrogen scale and vapor density. They'll also ask you guys about the parasitic adaptation of leech, which is in biology lesson 13, 4 mark. And they'll also ask differentiate between light dependent and light independent reaction, which is biology lesson 12. Differentiate between aerobic and anaerobic respiration, biology lesson 12. They'll also ask you guys mass and weight of lesson 1, which is differentiate between. I've already taught you guys how to do it. Next will be rocket propulsion, lesson 1, important 4 mark. And next I will ask relative molecular mass is equal to 2 times the vapor density. This is important 1 mark. So guys, I'll repeat it again. So important science questions, they'll definitely ask in public exam, obviously in exam as follows. So conservation of linear momentum, which is in physics lesson 1, male reproductive system of rabbit, biology lesson 13, types of inertia and Newton's laws, which is 4 mark. Physics 2 mark, solve the problems. They will definitely ask 2 mark from solve the problems in each of the lesson, which depends on physics and chemistry. No, they will not ask any questions from biology. I know what you guys are thinking. Plus, they'll also ask relative hydrogen scale, the relationship between relative hydrogen scale and vapor density, which is the important 8 mark, which is in chemistry lesson 7. And parasitic adaptation of leech, which is in biology lesson 13, structural organization of animals, and differentiate between light dependent and light independent reaction, which is in biology 12th lesson. So parasitic adaptation of leech, which is 4 mark, light dependent 4 mark, differentiate between anaerobic and aerobic respiration 4 mark, mass and weight 2 mark. I repeat, I'll kill you guys from the first. So conservation of linear momentum 8 mark, male reproductive system of rabbit 8 mark, types of inertia, Newton laws 4 mark, physics 2 marks, solve the problem, chemistry 4 marks, solve the problem, relative hydrogen scale is times vapor density is an important 8 mark, parasitic adaptation of leech, which is an important 4 mark, and differentiate between light dependent and light independent reaction, which is a 4 mark, differentiate between aerobic and aerobic respiration 4 mark, and differentiate between mass and weight, important 2 mark. Next one will be relative molecular mass is equal to 2 times the vapor density, which is an important 1 mark, And rocket propulsion is an important 4 mark from lesson 1. And the relative molecular mass is equal to 2 times the vapor density is lesson 7 at atoms and molecules. So I hope you guys study all of this. So even though I'll just give you guys a quick note of this. Conservation of linear momentum. That's basically all. And the next page. RMM, which means relative molecular mass is equal to 2 times the vapor density, which is an important 1 mark, and rocket propulsion, which is an important 4 mark from lesson 1. Okay, so the next one will be write the different types of isotopes of oxygen and its percentage abundance. So isotopes of oxygen isotope mass mu atomic molecular unit atomic mass unit. Last one will be percentage of abundance. So there are 3 types, guys. So O8, 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 16, 17, 18. The mass will be 15, 16, and 17. This is 0.9949, 0.9991, 0.9992, 9949. Remember guys, 15, 16, 17. So to remember 15, 16, 17, just remember -1 of the mass, atomic mass. Then remember, try to put, just remember 9949, 991. So imagine just remember the last digits. So it's properly 4 decimal points. So 4912, 4912, 4912. So yes, then the percentage of abundance, which is 99.759% and 0.038% and 0.205%. So just long number 757-308-205. 757. The most abundant, second most abundant, and the least abundant. So 99.579.308.20. Sorry guys, it's 0.038. Sorry, 0.038. So I hope you guys understood of isotopes of oxygen. Okay, after the short answers, also will go study. Next one they'll ask atomicity. So it's kind of easy. Then they'll definitely ask, give any 2 examples of heterodiatomic molecules. Fourth questions. So heterodiatomic, hetero, homo. So what do you understand from these 2 terms? So homo, which means same, and hetero means different. So they have hetero diatomic molecules. Hetero diatomic molecules. So hetero diatomic. So hetero means different, that means two, atomic means atoms. Different two atoms, but some guys will think, oh, Sharan, elements. But guys, look at this. Two, we do not want to. Instead, there's also another form for carbon dioxide, guys. Do you know that? Carbon monoxide. That's carbon monoxide. And carbon sulfide. And hydrogen iodide. There are a lot of reactions. NADR. HCl and HF. They will only ask two, so write any two. So I would basically recommend COHI, never COHI. Oh, that's all. But to be honest, this is easy, this is easy, this is easy, this is easy, this is easy. Yeah, fine. Next is molar volume of a gas. So, 1 mole of any gas occupies 22.4 liter or 22400 ml at STP, which means same condition of temperature and pressure. Okay, so this is it. So 1 mole of any gas occupies 22.4 liters or 22,400 ml at STP. Oh, so let's see, finally one viewer, and I guess he or she is watching us. So hi guys, I hope you understood all of the concepts that I taught so far very well. It is already 43 minutes. So now let's go for the next answer. Which is, find the percentage of nitrogen in ammonia. So find the percentage of ammonia in nitrogen. Percentage of ammonia. And find the percentage of nitrogen in ammonia. So ammonia So first, to find the percentage of something, we gotta find first the molecular mass. So molecular mass of NH4, which is ammonia, is equal to, so purely I gave you 10 billion videos based on how to find the molecular mass. So let's see how you guys do it. So N, there are how many atoms? There is nothing. So 1 times n plus H4. 4 atoms of hydrogen times H. So 1 into n molecule of n. So n2. So n is 7, 14. So it's basically 14 plus 4 into 1, which means 14 times 14 plus 4 is 18 gram. It's 18 gram, isn't it? So guys, I guess it is an H3. Sorry for the slight confusion, it's not NH4. NH4 is meeting. So NH3, remember guys? Sorry guys, I made a huge mistake. So it means 3 over here and 3 over here and 3 over here and 70. So to find the percentage of an element, is the atomic mass of an element by molecular mass of the element. So times 100. Because percentage means 1 by 100. 1 percentage is 1 by 100. So common sense. So atomic mass of the element. What element are you finding? Ammonia. So N, which is 14 by 17 times 100. We gotta divide it. It's a huge process. So 14, 17. So we gotta put 17 times first. So 17 and 17 times 2, 4, 1, 3, 34. And 34 times 7 plus 17, which will give us 11, 4, 5, 51. 51 times 17 is 68. 68 times 17 is 7, 8, so it's 85. And 85 times 17 is 7, 8, 9, 10, 11, 12, 2, 1, 9, 10, 100, 202 times 17 is 911. So 191 times 17 is 631. 136. 17. 31451. 170. So this is a table, guys, which we are going to do all of the sums and additions. So let's divide step by step. So okay, so 17 times 14. That's how I think it works. So 17 times 14, so is that 17? No. So you put a 0 over here. You put a, it's kind of rough. A 0 over here, and you put a point over here. 1, 2, 3, 4, 5, 6, 7, 8. 8 times is 136. 8 times is 136. So if you take 1, 3, 4, 0, 40, 40 or not 40 times 2 times. So you can put 2, 34, 1, 3. Again 6 times, 60, 60, 60, 60, 3 times. double fix is 51, 1 and 5, 9, 90, 5 times become 85, 1, 8, 5, 5, 0, 2 times 34, 1, 4, 1, 6. 1, 6 cannot come, so 160, 9 times, so 153. So it just goes on and on and on. It will never end. So, based on the calculations, we can tell that the answer is 0.8235 29 into 100. It's 100 times 100. So the decimal will move 2 places. So 1. So it is 82.3529% of NH3. Yes, guys, 900. So I hope you guys have understood everything and basically everything else. So thank you guys for watching the video. Bye guys, I'll see you tomorrow. Not even end. Yo, what?